Hi everyone, welcome to another lecture in the MATLAB Crash Course series. I'm Stephen Yagmore. Today we're going to take a look at switch statements in MATLAB. It's going to be a little bit of a shorter lecture, hopefully. Let's get right into it. Some of the topics that we're going to talk about today, we're going to look directly at the purpose of the switch statement and how we can actually use this when writing code. We're going to be using cases in the switch statement, how we use the case keyword and what cases are for when using a switch statement. We're going to take a look at the otherwise keyword, meaning how we're going to use default actions, what are we going to do if something doesn't match up. We're going to use the return keyword and the error function to exit out of a program early. And then we're going to compare switch statements with if-else statements and see when to use one, when to use the other, when it's best, because these two are going to be very similar, as you're going to start to see. So first, let's look at the purpose of the switch statement. So in the previous lecture, we discussed how to use if-else statements to allow for different actions to take place depending on certain input. If you have not seen the video on if-else statements, I'd recommend learning how to do those first before looking at switch statements. Because if you know how to use if-else statements, switch statements are pretty straightforward and make a little more sense logically. MATLAB allows for another method besides if-else statements for executing different actions based on different values, and this method is the switch statement. The switch statement is fairly similar to if-else statements, but the action, this is important here, the action performed is dependent on the value of a certain previously assigned variable. So unlike the if-else statements where you use relational operators to check, okay, is this number greater than 0? Is this number less than 0? If it is, do this. If it's not, do this. With switch statements, we have the user assign a value to a variable. Then we take a look at that variable and we say, what does that variable equal? If the variable equals this, perform this action. If the variable equals this, perform this action, etc., etc. We're looking at a variable. We're not looking at logical values. We're not comparing anything. We're just saying, okay, what is this variable we previously assigned? The general format consists of a variable that exists as the switch expression and multiple different actions depending on different cases. So let's kind of look at what that format looks like. So the block here to the right provides the format for a general switch statement. So the word switch right here is placed with a switch variable following it. So the switch variable can be any variable that the coder, whoever coded this, already established that exists. You might have it equal an input function. We'll say this variable equals input, and the user can enter whatever they want to. Depending on what the user enters will be whatever the value of that variable is. Then we look at that variable. So the switch variable must simply be a previously established variable whose value is dependent on previous events. The word case, so here this is another keyword, is then placed with an expression being some value that the variable could equal. So all the expression is just what could this variable, this switch variable, possibly equal? You put the variable name and then you put what the expression is. The expression could be a digit, it could be an integer, it could be a float, it could be double, a string, a character. I'm not going to list all the different data types. It could be any of these. And so all we need to check is, okay, does this switch variable equal this expression? And if it does, then the action that corresponds with that case is going to be performed. So if the switch variable is equal to expression 1, then action 1 will occur and it will skip everything else. Much like with the if-else statements, how it skipped all the other else statements or else-ifs clauses. It'll skip any of those actions. It'll find the expression it matches with, perform the action inside that little block under the case, and then skip everything else and proceed after the switch statement. So to actually demonstrate this, I have an example in which we can use the switch statement. So this is the first example. We have 4 different versions of this, each one kind of just proving a different point or explaining a different point. So it's called give grade. And it's pretty straightforward. We'll do more complicated examples with computation later. But so this script will print a message to the user depending on what letter grade they received in a class. So all we do is we ask the user to, what their letter grade, their final letter grade was in a class. And then depending on what their letter grade was, we're going to print a different message. So here what we do is we ask the user what letter grade you received, uppercase. We'll do an example where you can actually avoid uppercase, lowercase discrepancy because when you're doing equality, it does matter whether it's uppercase or lowercase. That's called case sensitive, where if it's uppercase or lowercase, they're 2 different things. We're going to do a different example in a second where we can actually avoid it. So it will be the same thing whether it's uppercase or lowercase. It's not case sensitive. But in this case, we want the user to enter strictly an uppercase value. And so what happens is these values are A, B, C, D, or F, your typical letter grades for a course. So what we do is we ask the user, and it's saved under this variable grade. Then what we do is we write our switch statement. So here, the grade is going to be the switch variable in this case. It's going to be the variable that we look at. In this case, it can be A, B, C, D, or F. And then we're going to compare it to each of these values and see which one it actually equals. So we put grade, and then here we're going to say, okay, does it equal A? If it equals A, then print this message here. Perform everything under case A. Then case B, meaning, okay, does the letter grade equal the letter B? If it equals letter B, then we're going to print this message. If it equals C, if it equals D, if it equals F, we're going to print those respective messages. Then at the very end, after all that, we're just simply going to print see you next year, so we know that it's going to skip everything else and then print see you next year after printing the corresponding message. If it doesn't equal any of these values, it's simply going to wait till the very end and print this message here. It's not going to print any of these because if it doesn't equal any of them, none of the actions will be completed. So let's actually give this a go. So I'm going to run this, give grade. What letter grade did you receive? Let's say we got an A. Congrats, you did amazing in the course. This is the message that we said would be printed if the user got an A. And then it skips all the other messages and says see you next year. We can run it again. Let's say we got an F. Well, the professor tried, they guess. See you next year. Once again, all we're doing is seeing what letter matches up with what case. What does grade equal in this case? What did the user enter? It's very similar to if-else statements, but we don't have all these equal signs. We'll do a little more comparison later. What happens if I enter a letter that is not what we specified? So let's say I enter H. H is not a grade we can get in a course. If I enter this, it simply says see you next year. It skips all those cases because H doesn't equal any of the expressions we defined. But say, what if we wanted to tell the user that they entered something wrong or that wasn't a letter grade? Well, in order to do that, we'd have to use the otherwise keyword. So the coder cannot predict every single value that the user could possibly enter. That's not possible. There's a lot of values out there. But to account for any extra cases the user could provide, so any like weird things, if the user put a number, if the user put a whole word, if the user put a letter that is not A, B, C, D, or F, we're going to use this otherwise keyword, saying that essentially we're going to have a default action be performed. What's going to happen is all the cases will be listed here. We're going to check the switch variable, see if it equals any of the expressions in the case. If none of those expressions match what the switch variable is, then we perform whatever's in the otherwise block. It kind of makes sense in English too. Here's a variable, perform, check all of these and perform the expression. Otherwise, meaning it doesn't work, we have a value that doesn't equal any of these. Otherwise, perform this final action. So if none of the, if the switch variable does not match any of those expressions, the otherwise action, the final action, the default action will always take place. The cases must be listed first though, that's how the formatting works, and the otherwise must be placed at the end. And like I said multiple times, if any of the case expressions do not match the switch variable, the final action in the otherwise block will occur. And so I have an example of this. So we modified our give grade script here to account for this. So in this case, everything's the same. It still asks the user for the letter grade. It has all 5 of our previously established cases. But here we have an otherwise keyword. We say otherwise, print here, that's not a grade you can receive, you fool. Essentially meaning that if the user did not enter in uppercase A, B, C, D, or F, it's going to print this statement right here. Which makes sense too in English. Perform these, otherwise perform this here if none of those match. And so if we enter anything that's not one of these 5, it's going to print this. We can see this in action. So let's say give grade 2. So what letter grade? Let's say we do, just to show, let's say we did B, you did well in the course, see you next year. Similar to what we'd see in the previous script. But let's say we put H this time. This time it doesn't just skip to the see you next year. It says that's not a grade you can receive, you fool. We specifically designed our own final action, a default action, assuming that the user entered a value that was not equivalent to one of the other previous 5, the A, B, C, D, or F. This can be really useful. If the user enters something that doesn't work, it's going to skip the rest of the code and do something wonky. But in this case, we have a default action. We can say, okay, in case the user doesn't do this or enters anything else, we can have this happen. It's very similar to the else in the if-else statement, kind of like where we had our if-else statement saying, if this, do this, else if, do this, else if, do this. else, meaning if none of the other if or else if clauses worked, we performed this. It's very similar to that, but in this case, it's the otherwise keyword. So now I'm going to talk about the return keyword and error function. So sometimes a certain user input might require the program to end early, such that any following calculations do not take place. If the user enters something they're not supposed to, and then you use that variable down the road to do calculations, those calculations will not be able to be completed. An error is going to pop up. But we can actually end the script early and prevent any weird calculations from happening, any other errors from taking place. And so in order to end a script early, one can use the return keyword. Essentially what will happen is that, let's say in a certain switch case or in a certain block in an if-else statement, the user wants the script to end early for some reason, we can place the return keyword. Once MATLAB for any reason reaches that return keyword, it's going to immediately end the script and not perform anything else. It will immediately cease all other actions that could possibly happen in the script. Generally, one will have some type of message be displayed using disp or fprintf to tell the user the reason why the script ended, or just saying that this happened, ended. And so I have an example with this right here. This is the third modification of give grade 3. So it does the exact same thing, but this case, let's say the teacher is kind of passive aggressive, and if you got an F in the course, we don't want to print out this see you next year. What we can do is we can put this return keyword right here in case F, meaning that if the user enters an F, it'll print out this message here, and then it will return, meaning it will immediately end the script. If it's any other case, if it's A, B, C, D, or if it's otherwise, it'll still print see you next year. But in this case, if they enter F, since we have this return keyword, it's going to stop the action, and it's not going to print see you next year. So let's try this one to demonstrate it. So let's do give grade 3. So let's do C. So it says not too bad overall. It still says see you next year though, because it's at the end. But if I enter an F this time, it says, well, I tried, I guess, but it doesn't print the see you next year. And that's because of that return keyword. We had that return keyword, so it ends the action. It doesn't do anything else. We can actually do one better even. Let's say you wanted to actually pop up like a real error message like MATLAB and give you the line that the error happened. We can do that by using another function called the error function in MATLAB. The error function will act as an error message in MATLAB and tell the user the exact line where the error occurred. So we can actually change what we have here. So let's say if they enter an F, we want an error to be printed instead. We can say error. And then we can put in here, let's just say as a joke, you did not do too well because of this MATLAB broke. So let's say that if you enter an F, MATLAB's so disappointed because you failed the course and it's so sad that it just broke MATLAB overall. So let's see what ends up happening in this case. I think I have it all entered correctly. Yes, let's save those changes. So give grade 3. So once again, if we enter anything else, it's normal, but let's say in this case, we enter F. It's going to pop up with an error function. It says error using give grade 3, line 18. You did not do too well because of this MATLAB broke. So it looks like a normal error function that we'd get if you actually used MATLAB and you did something wrong when you ran your script, or you typed something wrong and you got an error message. If you're familiar with just coding and debugging, error messages will pop up constantly. They're unavoidable. It's not fun. And hopefully in the future I'll have a video on debugging with MATLAB and how to check your code a little bit better. But so this did not do too well because of this MATLAB broke. So this is more like an error function. We can use this instead. And we can also see it ended the script early also. It also did not do anything after it hit that error function. It didn't print the see you next year because that's how the error function works. Similar to the return keyword, it ends the script early. So now we have a couple examples where we can use all these skills we kind of have. So the first one's fairly straightforward overall. So it says write a script that will calculate the volume of either a cube, pyramid, sphere, or cylinder, depending on user input. Ask for the correct types of dimensions after the user has indicated the figure. All right, so let's create a little script that we have here. So essentially all we're doing is we're just finding the volume. Oh, we don't want to save, we want to make it new. We're just finding the volume of various figures that we have, various shapes. So we're just going to call it find volume. The purpose will be this script will calculate the volume of a given figure depending on what type of figure the user would like to calculate for. All right, so first thing, ask the user for the type of shape they want. So here we're gonna first ask the user, okay, what type of shape do you want to calculate for? So we can say shape equals input, enter the shape you would like to solve for. And then we need our S because they're gonna enter a string in this case. They're gonna say sphere, cylinder, etc., etc. So we have that. So then in this case, we have to see here, there are a few options. It could be a cube, pyramid, sphere, or cylinder, depending on what the user says. So we need to calculate for all of these and make sure that the correct dimensions are being asked for and make sure everything works properly. So since we have multiple different things it could possibly be, and we're testing for equality for whatever our variable is, we're going to want to use the switch case statement here, the switch statements. It's going to be the best bet in this case. So we can say switch, or first let's leave a comment. We're going to say solve for volume depending on user input. So then we can write a switch statement. The variable we're going to be testing for in this case is shape. We want to see what did the user enter for shape. So we're going to say shape. So what kind of cases do we have here? Well, one case it could possibly be is going to be sphere. We could possibly be solving for the volume of a sphere. So what kind of dimensions do we have to ask for in this case? Well, since we're solving for a sphere, the only type of dimension you need in this case is going to be the radius because the volume is 4/3 pi r cubed. So we can just ask for the radius. Then we can say radius equals input, enter radius. It'll enter the radius. Then we can say volume equals, and in this case it will equal, 4/3 times pi, times the radius cubed. Fairly straightforward. So we solve the volume just like that. So now we have another case. We could possibly be solving for a cylinder. So what do we need in this case? In this case, we need two separate dimensions. We need a radius for the cross-sectional area of that cylinder. We also need the height of the cylinder in this case to solve for it. So we can say radius equals input, enter radius, and then we can say, in this case, height equals input, enter height. So we have the radius and height. Now we can solve for the volume. The volume is going to be, and for a cylinder in this case, it's going to be pi times the radius squared times the height. So you can say pi times radius to the second power times the height. And that's going to be the volume in this case. What else do we have? We also have a cube it could possibly be. In this case, we only have one dimension we need for a cube, and it's going to be the length of the side, because for a cube, it's just the length of the side to the third power. That's why it's called a cube. You cube it. That's why it's called cubing. So we're going to say side is going to equal input, enter side length. I'm not going to use length because remember, length is a function in MATLAB, and it can get a little confusing. So I'm going to say enter side length. And then to calculate our volume, you could say volume equals side to the third power. Fairly straightforward. Then we have one more case it could possibly be, and that's going to be the pyramid. Just like that. So for the pyramid, what all do we need here? Well, so in this case, if we remember correctly, for a pyramid, it's going to be 1/3 times the height times the cross-sectional area of that pyramid. We're going to assume it's going to be a pyramid with a square bottom on the outside. So we need to do 1/3 times the height. So we need to know the height of that pyramid. How high is it right off the bat? And then we also need to know what its cross-sectional area is in that case. And since it's a square on the bottom, we just need the side length. So we can say side equals input, enter side length. And then we could say height equals input, enter height. And then volume is going to be 1/3 times, not pi, it's going to be times the height, times the cross-sectional area, or the area on the bottom. And the area on the bottom is going to be the side squared. So it's going to be side to the second power. And that's going to be our volume in this case. So now let's say the user enters something that's not any of these four shapes here. Well, that's not what the purpose of this program here is. It has to be a sphere, cylinder, cube, or pyramid. So in this case, we can have a default message occur. So we can say otherwise, let's assume none of these were printed. So we're simply just going to say fprintf, you must enter a sphere, or you must enter sphere, cylinder, cube, or pyramid. All right, so it just simply displays that to the user. So then we can just say end our switch case. So here we have our switch statement all set up. We're going to say what kind of shape did they enter, and then it's going to choose between one of these four, and if it's not one of those four, it prints a default message. So now we're going to calculate, we're actually going to display the volume to the user and tell them what it was. So then we can say, we'll just say display volume to user. So then it'll be fprintf volume. Actually, yeah, let's just do volume. And then we can give it to, say, 2 decimal points. So 0.2 f-n, and we're going to print volume. Now we have to be careful about using this here. We're actually going to come up with an error if we enter anything that's not a pyramid, cube, cylinder, or sphere. So let's actually try this out first of all. Actually, let's exit out of this. Actually, let's first... Okay, so find volume. Enter the shape you'd like to solve for. So let's say we did a sphere, like normal. Enter the radius. We want the radius to be 5. Cool, it gives us the volume, 523.60. That's cool, but what happens if we enter something that's actually not any of those? Blah. I want to solve for blah. You must enter a sphere, cylinder, cube, or pyramid. But it still gives us that 523.60. Why does it do that? Well, the reason it did this is because over here, we still have shape, not shape defined that, we still have volume defined by 523.60. But we don't want it to actually print that volume out. We just want it to end. We don't want it to display this volume because it didn't enter sphere. The way we can do this is by using the return keyword, like we talked about. So we can have it print this message, and then we can say return. And then it won't print the volume out because it'll immediately end the script. So if we try doing this again, let's say I do the exact same thing. I say blah. Now it doesn't display a volume. It says you must enter sphere, cylinder, cube, or pyramid, but it doesn't display this volume because of the return keyword. Works very methodically. Now, one thing we can kind of do to make this a little bit cooler, if you'll notice here, if I try find volume, it won't solve anything if I enter capital S for sphere because it's case sensitive, meaning it must all be lowercase in this case. We can actually do something in here, just a little cool tidbit. I can use a function that MATLAB has called lower. Lower and surround this variable. What lower will do is it will look at your string, and any letters that are uppercase, it will turn to lowercase, which is really cool. Let's actually look at this right here. So if I say lower the string dog with a capital D, it'll output dog with a lowercase d. So I can use that in this case to actually make it so it works and is not case sensitive in this case. Since I surrounded lower, what will happen is it'll take the value the user entered and then it'll make all the letters lowercase. So when it compares to all these, it'll all work perfectly. So notice how last time when I entered sphere with a capital S, it did not work. Well, if I enter sphere with a capital S this time, now it works and it asks for my radius because I use that lower function. Just something that's a little interesting and thought I'd point out. So that's a pretty straightforward example, but so this example, this one isn't all too bad. But let's take a look at this one. So Clearwater Bank is initiating a new rewards program to better benefit its members. All Clearwater Bank members can now opt for one of 3 types of credit cards: silver, gold, or platinum. Interest rates compounded monthly for these cards are 2%, 5%, and 8%. Respectively, compared to the 0.4% for non-reward members. Create a script that allows for the user to enter their monthly earnings along with their reward status and display the amount they will receive in interest for that month. So in this case, this is kind of interesting. So we could have a different rewards program. You could be silver, gold, platinum, or no rewards. And depending on that, you have a different interest that's compounded monthly. Now, these interest rates are extremely high monthly. This is not realistic at all. This is just for calculation. I wish my interest was 8%. Trust me. But yeah, that's not realistic in the slightest. But so let's actually try this. Let's make a new script. Let's see. Let's call it Clearwater because we're at Clearwater Bank. This script will calculate the monthly interest for a member of Clearwater Bank depending on their current rewards status. So first, we're going to ask the user for their reward status and what they are. So let's provide some options for the users. Let's not have them say gold, silver, platinum, etc. Let's have them enter a letter. So either G, N for non-rewards, S for silver, P for platinum. So first let's print F. Let's see, how should we say here? The types of reward status are as follows. So we're just going to show the user what kind of different rewards or what they should enter. So we're going to then print F. So first there's silver, so we're just going to say S, silver. F, G, gold. F, P, platinum. F, let's see, there's platinum, and then N for non-rewards member. Then we can actually finally ask for what the reward status is. We could say status equals input, enter rewards status. And we need to make sure we have the S and apostrophes because they're going to be entering a character in this case, either S, G, P, or N, or if they don't follow instructions, some other character. So we have that. So now, determine interest rate based on status. So now in this case, we have a few options we can choose from. So it's either going to be 2%, 5%, 8%, or 0.4% depending on what their status is. So in this case, we need to see exactly what the user entered. Since we're testing for equality, we want to see what character they entered. We're going to want to use a switch statement in this case. So we can say switch. What variable are we going to be looking at here? Well, there's only one variable we decide. It's going to be status. We're going to try to determine what their status equals at this point. So let's see, what kind of options do we have? First case is going to be silver. If it's silver, then we're going to say that their rate is going to equal 2%. And instead of writing 2, I'm going to just immediately turn into a decimal and say their rate's going to be 0.02. We have another case. The case is going to be gold. If they're gold, then the rate's going to be 0.05. If they're platinum, the rate is going to be 0.08. And then if they're non-rewards member, their rate is going to be, in this case, what's the rate going to be? It's going to be 0.004. Not too high. You should get on that rewards program. All right, so what if the user didn't enter any of these? To have a default action take place, we're going to want to use the otherwise keyword. I didn't put a semicolon there. Let's make sure we always put semicolons. So then, otherwise, what should be printed? Well, we want some kind of default message. So we're going to say fprintf, please enter one of the specified characters. Because they did not follow directions. And in this case, we don't want anything else to happen after this, so let's go ahead and use that return keyword. That return keyword is going to be helpful so that it doesn't end up calculating what their interest actually is. And then we end it here. That's the end of our switch statement. We have all the possible cases to test for. So now we're going to, let's see, what should we do now? We need to actually calculate the monthly interest. So calculate monthly interest. And then that's going to be accomplished. We could say interest is going to equal, and what's going to equal in this case? Well, it's just going to simply be whatever their rate is times their monthly earnings. And that's one thing we actually forgot. So the user also has to enter their monthly earnings. That's one thing. So that should actually be the first thing they enter in this case, is going to be their earnings. So their monthly earnings is going to be input, enter monthly earnings. Sorry about that, forgot that variable. We need to know what their earnings are if we want to actually calculate what their interest is going to be. So all we have to do then is, since they enter their earnings, we just need to take their earnings times whatever their rate is, and that's going to actually give us what their interest is going to be for that month. Pretty straightforward overall. So that's what we do. And then finally, print interest to the user. So then we're just going to say fprintf monthly interest. We'll put a $sign, and then let's go to 0.2%. We use the f because it's float. And then what value we're going to put here? We're going to put whatever the interest is. And it's all we actually do. So this one's actually not as bad as the last one, I guess. So it's pretty straightforward, pretty methodical. We use the switch statement here to actually just simply go ahead and say boom, boom, boom. What does it equal? If it equals this, assign that value as such. Very straightforward, good for quick computation. So let's actually run it. So let's go ahead and try to run it. Let's clear that. Clear water. Enter monthly earnings. Let's say we got $5,000 this month. All right, so we got a few reward types. What kind are we? Let's say we're gold. It immediately calculates, and it says it's 5%. It looks like it pretty much checks out in my... Oh, yeah, 5% of that's... Oh, 5% of that's good. Oh, wow, that's 50 times. Yeah, I wish interest was that high. Tell you about that. Monthly interest, that's insane. So this is not a realistic example at all, but it does check out. That is 5%. Like you kind of get your bang for your buck at that point. You may as well go to that rewards program. But let's see what happens if we enter something that doesn't work. So enter monthly earnings. Let's say I say 4,000 for monthly earnings, and then for my reward status, I put no. So it says, please enter one of the specified characters, and it immediately ends the program. It doesn't try to calculate what my interest is, and it doesn't try to depict it to me, which is good. That's what we want. That's why we use the return keyword in this case. So those are a couple examples that hopefully help. The final thing I'd like to talk about and just touch on is the switch versus the if-else statements. So the switch statement and if-else statement, as you probably noticed, they perform pretty similarly, but there are a few key differences between the two. The switch statement can only be used when one wants to test a relation for equality. That's the only way we can use a switch statement. If you want to test directly, what does it equal? What does this equal in this case? Does it equal A? Does it equal B, C, or D? Does it equal any of those? If we want to test that, we can use the switch statement. The if-else statement can perform the exact same functions as the switch statement, but equality operators must be used to return a logical true or false. So we can use anything we can do with a switch statement, we can actually turn into an if-else statement. There's no case where we can't use an if-else statement to model what a switch statement does. So we can actually show this, and that's what GiveGrade4 is. GiveGrade4 is the exact same program as I think the third GiveGrade, or the second GiveGrade. Does the exact same thing, but in this case it uses if-else statements. We say if grade equals A, if grade equals B. Notice I can only use these double equal signs because this is a character. If this was a string, this would not work. Only because it's one character does the double equals work. Make sure you take note of that. But so we can use this if-else statement in this case, the exact same way that we use the switch statement. They're the exact same thing. They perform the exact same function. They look pretty similarly. What's nice about the switch statements, though, is that we don't have these equal signs. We don't need to keep saying it. All we say instead are, okay, here's the variable. Which one does it equal? It just looks a lot nicer than having all of these equal signs, and it's a lot more cluttered in this case. Everything's more spread out with the switch statement. However, the if statement is more powerful because, unlike the switch statement, the if-else statement can test for other relational operations, such as the less than, greater than, less than or equal to, greater than equal to. The switch statement cannot be used to test any of these. It can only test equality. It can only test, does this variable equal this number? It can't test, is this variable less than 0? Is this variable greater than 0? It cannot test any of that. In general, switch statements should only and can only be used to test equality. And that's it. If-else statement's more powerful. Anything you can do with a switch statement, you can turn into an if-else statement. But not everything you use an if-else statement for can be turned into a switch statement because of the greater than equal to, greater than, less than. All those cannot be used on a switch statement. So make sure you're conscientious of when you can actually use the switch statement. But used correctly, it can look a lot nicer than the if-else statement and honestly looks like better code in general. And that's all I have for today. Thank you for watching.